Hello and welcome. Let's talk about the mean. The mean is a measure of central tendency. It means if you have a set of values that you'd like to get an idea of where the middleness is of that set, the mean is one way to do that. The mean of a set of values, I'm just going to introduce this notation. It's represented by this little x with a bar over it. In words, it's the sum of all the values divided by the number of values, how many values you have. And so in shorthand notation, just to introduce this to you, we'll use this symbol, which looks like an E, but it's actually a capital Greek letter sigma. Really, it's just a symbol for sum of. The sum of all values x. This x represents each one of those values in turn, and divided by the number of values, which we'll call n. So just introducing that notation so that when you see it again, you'll recognize that that's what that means. But it's really just add them up, divide by how many numbers there are. That's basically it. So there's two ways to think about the mean. One is the balance point, and the other is a leveling out point. So balance point, let's look at just the mean of two numbers. Simplest mean we can think about, and that's also known as the midpoint. Standard average between two numbers, right? Let's say take the midpoint of, say, a 4 and 8. Well, you add them together and divide by 2. As you'd expect, that's 6. So you can kind of visualize this on a number line here. So here's 4, 5, 6, 7, 8, and here's 6 right here. You can think of this as where you'd put the fulcrum if you're going to balance two weights, one at 4 and one at 8. So that's what I mean by a balancing point. If we start adding more numbers, the mean gets kind of little. There's no midpoint to be talking about because you got too many numbers. So it gets, this balancing idea makes more sense. Let's find the mean of these numbers, 2, 3, 7. Well, we add up the numbers, sum of the values, 2 plus 3 plus 7, divided by 3. That's 10 plus 2 is 12 over 3, so this is 4. How you might visualize this is, here's 2, 3, 4, 5, 6, 7. 4, 5, 6, 7. The mean is 4, 2, 3, 4. So the balance point is here. So if we have a weight at 2, a weight at 3, and a weight at 7, that point right there is where it would balance. So how does this relate to the leveling out point? Well, imagine that instead of adding 2, 3, and 7, we just added 4, 4, and 4 3 times and divided by 3. We'll get the same number, 12 over 3, or 4. So basically what this means is if you replace every single one of these numbers with the mean, which is 4 in this case, you'll get the same mean. So 3 weights at 2, 3, and 7 is the same as just stacking 3 4s. Let's look at 2, 3, and 7 as sizes of stacks of blocks, say. What I mean by leveling out point is asking the question, what level would these blocks be at if I could rearrange them so that they're at the same level? I'd have to take some of these blocks, I'm not sure how many just yet, and move them over onto the other stacks so that it's all at the same level. Well, here's one we could put down, so let's take off that one. So to get the same level, let's take out 2 more out of the 7 and put them here. So let's take out 2 more. Oh, and now we're at this same level of 4. You can imagine these, if these aren't integers, if these aren't nice round numbers, you could imagine them as piles of a certain height, or water at a certain height. So you could think of this the same thing as 3 glasses of your favorite beverage, one that's 2 centimeters, one that's at 3 centimeters, the other's at 7. How would you pour the 7 into these so that they would be at the same height. And what would that height be? Well, that height would be 4, be the average of those three numbers. Now note that the mean doesn't say anything about how spread apart the numbers are. So for example, the numbers 99, 100, and 101, the mean there is 100. By the same token, 1, 100, and 199, the mean of those numbers is also 100. So they could be really spread apart or really close together. How spread apart or how close they are together, that's another measure of data called standard deviation that we'll get to later. But that's enough for now. See you next time.